today's lab, I would like you to log on to the Amazon AWS Learner Lab environment. And what you see on the screen is what you should be familiar by now, which is the console of your account. And today we'll do something new. We will now look into how you can use the EMR and create a cluster. And based on the lab instruction that you have access to, you can look at the second page and there will be instruction how you can begin. What we'll do is we'll go to this option EMR, or if you look at the possibility, you can put EMR here and you should be able to find this. So EMR stands for Elastic MapReduce, and what it can do is to allow you to create cluster using the kind of pre-defined setup, so you don't really spend time configuring, and the cluster will be able to be automatically usable right once you set up. I'm going to go through and show you how it works. So let me just at least hide the previous ones. I think they are terminated, they are not needed. So first thing what you do is to go to create cluster, and you see here look very familiar with what you have done so far. So based on the instruction, I think you can put app 5, right, and maybe your name. I'm going to just put here Hadoop, right, and I will suggest take the latest 7.13. Okay, and here you can see there are options, and I think what we need for our exercises now will only be Hadoop and also Spark. So you just keep these two, and the rest you can leave it empty. What you do next, you just keep everything the same, right? And you can see on the instruction I have included quite some details that you can follow. First of all, keep it to instance group, and here you can choose something smaller, right? And I think M5 will be actually good enough, so you probably want to take a large one. You may also take something smaller, but I don't think you can get any. Okay, you can get a medium one, right? This should also work, but I think for reasonable work, you may want to just keep it to M5 large. You can see the difference is medium has only almost 2 GB memory, and X large here will give you a 16 gig memory. So you can see the big difference between the capacity, right? So I think let's keep to this one. All right, next you go to the core and just choose the same thing. All right, so M5 and X large, and feel free to try something smaller, right? I think there's nothing wrong. And you do have enough credits, right? So go ahead and try it out. The next one, we will not have any task nodes, so you can remove them. And if you scroll down, you can keep this as they are. And here we will set the cluster size manually. For this round, we keep it consistent, so we will create 2 core nodes. These are similar to what you have done earlier with 2 slave nodes, 2 worker nodes, and I think putting it 2 will be identical. The rest you can keep it same. And when it comes to the security groups, right, do check that you can have a MapReduce primary core. I think you can leave it. These are the standard configuration. Next thing, you might want to look at some of the options. You don't have to do anything, but at least take a look and understand what are things you can configure. But more importantly will be the EC2 key pair. So I think we can leave the security configuration empty, but here you can put for key because we will need to do SSH into the cluster. All right, and now for the rows, I have already put the details on the lab sheet, but you would choose the default rows for this exercise. And at this point, I think you have gotten all the configuration right. So you can review them again. First, you give a name that can represent the application that you want to work on. Select the latest version 7 EMR, and also select Hadoop and Spark. Then the rest you keep it, and make sure you select the right instance type. I recommend something like X large would be good. You can also go for medium. I think it should still work. Then next, you can remove the task instance group, and here select number 2 for the instance size. The networking, you can keep them as it is, but here the security groups, do select MapReduce primary and MapReduce core. Next, you can skip the rest, or you can evaluate them, or at least take a look. But next configuration is to make sure you select Voki, right, as your key pair. This is important because for this exercise, you need to use SSH in order to enter into the system. Then finally, select the default rows, right? The primary row, just select default row here, and the EC2 profile for the EMR will put EC2 default row. And I think that's everything, right? We are not doing any automatic scaling, therefore you can just leave it. So when you're done, you can see the summary of everything is here. And if they are all good, let's go to create cluster. So looking at this is really not too different from what you've done previously, but the interfaces will look slightly different. Okay, for example, here you don't see individual instances, right? It's not EC2, but you can come here and look at the hardware where you will see your primary node and also your core nodes. So there'll be 1 here and 2 here. They are now being provisioned. So we can go back if you want to see a bit more. I think these are details that you can take a look, but there's not much to see here. So what we'll do mainly is just to look at the instance. So this process will take some time, right? You can either refresh and look at the statuses. If not, do take a break, review the questions that we have on the screen here, on the document, right? And also, I think you can go back to here, EMR. You can see we are starting the new one. These are the previous one that I was testing. So if you keep active, then you only see the one that's left. So a good thing with this EMR is that by default, once it's done, it will also terminate. And of course, you can also terminate them manually, right? That's to make sure you don't pay for anything that you are no longer needing, right? So you can always click on the cluster ID to go back to your detailed views, right, to see what status you are having. So you can see here, bootstrapping the system is already ready. And what I want you to pay attention to is the public DNS or the public IP, because we will use this to log onto the system. Waiting, I will change the video a little bit. This part of the recording is done after I've completed the main preparation, and therefore some of the numbers may look different, but it doesn't matter, it's the same thing. So what you see here would be the master node, primary, and from here I want you to look for EC2 instance ID, because from here I would like to show you how you can configure the security group to include SSH. So once you click on the instance ID, you'll be brought to the EC2 interface, which I think you are familiar with it now. You can see there's an instance ID here that I want you to click on it. And from here, you can go to the usual place under security to look for the security group. And you can see for most of our setup, if you don't change anything, Elastic MapReduce minus master would have been the default security group for your master node. So if you click on it, you come to the rules, and if you observe, you'll find out that all the ports are well defined for Hadoop services or even Spark. But what's missing here is there's no SSH being defined. This also means if you want to use SSH to enter into this master node, you will not be able to connect because SSH is not allowed. Therefore, I want you to come here and select Edit Inbound Rules, which after you click, you'll be seeing this, which you are also should be familiar at this moment since you have done it in the previous lab. Just click on Add Rules and select SSH. And since you want the people to be able to log in from anywhere in the world, therefore you have to put 0000/0. Once done, you can click Save Rules, and the security group has been updated where now SSH can be enabled. Based on this, you have just changed the masternode's security group to enable SSH, and now we can return to the main video again. So if you can, then you can also go to page 3 and get ready, and there will be these instructions that you can follow to log on to the primary node. So let's refresh, and you can see now the core nodes are also getting ready. And as we see, these are the instance type and the IP address and all this. And there's no longer the need to set up the IP, the host file and all this, because now Amazon will prepare everything for you, that you only focus on implementing the code. So what we can do now is to take a look at this. Let me see. So what we'll do in between is to get ready the login. So what I want you to try now is to click on Cloud Shell, where don't worry, nothing is lost. Your instance information are still up there. You can see some are already ready. So you can see the nodes are running, which is pretty fast. So what we'll do is, you can see now you have a shell, and this is actually a kind of like place you can start. And I have already copied the Voki files to my shell. But what you can do, right, for you, I think you don't have it, you can go back and you can go to AWS details, and this is where you can download the PM file. Now you can click on this and you should be able to download this file. I've previously downloaded. For you, you may not see this, but you can keep it at any names. Yeah, so for me, I already have it, that's why I will be replacing it. Now if you go back to your Cloud Shell, what you can do is to go to Action and click Upload File, and go to the folder where you have stored the labuser.pm file, which is like me here. Click on Open, and we will upload this file to your Cloud Shell. When it's successful, you see the same thing. And what I want to do next is, if your current Cloud Shell do not have the SSH directory like me here, then you can run the command mkdir.ssh, and that's where you can create the folder. In my case, I already have it, so I don't have to do it again. And even if you click on this, it will say the directory exists, and therefore it's good. So the next thing, I want you to follow the instruction to move the lab into the SSH folder, but save it as Voki, right? That helps you to differentiate, that know what file this is. Okay, so we can ignore the one that I already have uploaded earlier, and now you can move it there. If you now check what is inside this folder, you will be able to see Voki is also inside now. With this, the next command you need to execute is to change the mode to read only by root or by the user. Therefore, you can see the command is this. And finally, you are ready to do the SSH. So what we'll do is you scroll up a little bit, look at your primary node, and then you will be able to see the IP or the DNS here. So what I want you to do is copy one of them. So let's try the long DNS name. What you need to do is to press SSH -I. Okay, you got it. Put the user Hadoop, and this is the place where you will paste the public domain name. So when you're ready, click enter. You can see it will tell you that you are logging in and it's for the first time. This is unknown, but you can put yes, and next you can see, yep, we are now in the computer. How do you know? First, you see the welcome screen, the EMR. You also see the IP address, which is the private IP address of the cluster. And once you're in, you can even run the command that you're familiar and see which services are running. So in this case, you can see main and also JPS is running. And the next command you would like to try in part 2 would be this, so that you can also have a look whether HDFS is running. And you can see here we have the system up and running. You can even see some of the details, means everything is good. So at this part, we can now go to part 3 of the exercise. So for part 3, I would like you to now download one of the file, and based on the instruction, you can see you can download it using curl. And I've also created a shortcut that should be valid for the next foreseeable time. And what happens is you go download the file from the link I've given or I've set up, and you store it in tmp as committees.txt. So you press enter, you see like as if there's nothing. But if you want, you can always check if TMP already has the file. Yep, you can see now Comedies is already in TMP. What we will do next is to create a folder, right? You can see it's a command that you're familiar with, Hadoop fs minus mkdir minus p, and this is the folder name. Clicking enter, it's done. And if you want, you can always do the -ls to check the content. Well, but we will do that later. So the next thing, you can now upload the file. So you can see you're gonna put the file from tmp comedies to Hadoop folder, user Hadoop lab 5 comedies. And by right, everything should work without problem. Now you can do the viewing, and if you do an ls user Hadoop, you can see the file comedies already exist there, which is a good thing. And now you can try the next command to look at the content. Be very careful, make sure you have the head -n10 so that you only look at 10 lines and not the whole file. So you can see this is the first 10 lines of the file, which is showing that it's working. And you can even do this command right as given in the lab, so that you have some idea, right, to see what this file is about. So healthy is a good sign, right? Where, how many blocks and all this, you can always see those details. Okay, so the next thing is in 3.2. I would like you to repeat the same thing, but now you are working on S3. So let's do this to make it clearer. By putting this command, you will be looking at the S3 folder. Okay, for you, I think you probably will see, this is the S3 address that you have. So from here, what you can do next is to repeat this. That I will just first copy half the command. You can see almost the same thing, but now it's AWS S3 CP, which is copy. This is where the comedy dataset is. You're going to put an S3 and copy this part so that you're pointing to your S3 bucket. And here, do not stop, but to put there, this is where you want to store the file after you have uploaded it. So if you click now, you can see file has been uploaded. And if you now do a AWS LS, and of course the same place, you will see, right, there's a pre-lab 5. Okay, and if you put this, I forgot a slash, now you can see comedies.txt. Alright, so the backslash is important because here, without you're looking at this item, but we want to see what's inside lab 5, right? And that's where you can see comedies being uploaded. And to check, you can even now use Hadoop, right? And imagine running this, just treating it just like how you have done it earlier, and it will still work. So you can see Hadoop can be connected to the S3 bucket, right, where comedies is also found. So if you even go to the command that you're familiar with, we can also read the file, right, just like previously. So the command that I put there is bucket because every one of you will have a unique bucket ID. Therefore, you have to do the first command here to get your bucket ID. Remember to copy only this part, and now you can keep them after S3 to point to your bucket. Alright, so comedies.txt, and remember, make sure you only look at the first few items instead of everything. You should be able to see the first 5 lines. Okay, so based on this, we have completed part 3, and now let's move to part 4 to start with MapReduce. So for the MapReduce exercise, let's keep the screen clean again. It's not too different from what you used to. Okay, the command I have given earlier, and you can use the same thing, right? You can paste it, and you can see it will give you a warning just to make sure, right, we don't copy a script from an unknown source. But this is from my lab exercise. I hope you can trust my instruction. So it's good that it asks. So you can see first you have the Hadoop jar, and also, right, the jar file, and you can see word count. And of course, this is the data set, the input, and now you're talking about the output. So by pasting this command, MapReduce will start automatically, and I can probably assume this is not something unfamiliar at this point. You must have seen this before with your previous exercise with the AMI Hadoop cluster that you have created. So with this, you can see everything has completed without problem and pretty fast, right? We do have a pretty powerful machine here, right? So to see the output, you can check the output folder. So this will be the content, and of course you can now also view some of the content there. So let's look at the first 20 character that is being captured. So you can see not too bad, not the best, because by right the characters should not cover symbols, right? But we didn't do any filtering, therefore this is not a problem here. Secondly, I would like you to also look at the time needed. So you can see this is the time taken, right? And you might want to take note of this and compare with the next command. Next command, we're going to do the same thing, but now you'll be reading from S3. And we can see the bucket name is not what you want, right? And you execute it immediately. Therefore, you may want to modify the command. So what we'll do is, let's go back where you have the, where we have the AWS, right? Okay, we can't find it, so let's just type it again. S3ls. You will get your bucket ID, and you will want to replace them, right, with bucket on your file in your exercise. So let me do that copy and paste first. So that once we paste, we have all the data correctly, right? Of course, you can type the whole command, but just in case you make a mistake, then it's quite hard to find out. Okay, so let me finish copying the command. Okay, I got it. So let me see if I can paste it correctly. Alright, you can see here now I have a command with the S3 bucket, your ID, right? So I'm going to read from here. Let me see. It's going to be word count. Should be reading from comedies, right? Do I have comedies? Yes. And then output to here. Okay. Looks like I have an extra line which I do not need. Oh, actually we can edit here. So now actually you could have just edit. So this will be the first command, right? That you need to do. And then paste. And you will see it's being executed first. And then it won't be too different, right? And we also want to look at the time, so you can compare this and maybe the time earlier. So it took about 29, almost 30 seconds. Let's see how fast this go with S3. Well, it's comparable, right? It's not too different. So now I will want to copy this, and of course you need the right bucket name. So let's move the bucket and paste the ID, and you should be able to view, right, the output. So this part is still similar to what we have done earlier. Okay, so with this example you can see you're running the same exercise with word count, but now your storage is not on HDFS but on S3, right? So this is how you can use S3 object storage to carry out your big data work. Next, we'll be trying out part 5, which is PySpark. For this part, right, we will be following the instruction given. What you need to do first is to get ready PySpark, and this part you should be familiar because we've done that in our previous lab 4, and after a while you see it's ready. We're going to do the interactive one first. So once it is ready, we can then copy and paste the how you call that? Yep, the commands. So the first two will be these 2 lines. So you can paste when it's multiple lines. You can see this is how you include this, and now make sure you read the file from the folder, and you can already do a count. So we'll see this is reading and this is counting, and a job has been started, right? And then we'll get the sum of the total lines, which is 49,099. So to do word count, you can copy the commands here, which is something you have seen before. We want to see the first 20. and you can see this trigger another action. And this is already the first, words counted, right? The first 20 rows. So in order to do this, and you want to record the time, you probably want to keep, right, this here with the start time, and you can paste this to calculate the time. So how long does it take to do the counting, right? Here you can see this is the time needed. So with this, we can even try the next example. What if we want to do a average word length? That will be another example. So you can see this is the command, right? Take some time, copy and try it out. But more importantly, later take time to understand what the code actually means, so that you can also learn how to implement your own in the future. So here you can see we only want to look at the first alphabet, and then we calculate what's the word length, and later the average of it. And right, the code can actually give you those things, right? And now if you want to time it, right, set the start time, and you can look at the command again. So you're going to trigger the action, and then after that you can calculate how much time it has taken. So for this section, once you're done with the previous exercise, you can actually use quit to leave the PySpark prompt. And what I'll show you in the last part is how you can then execute a Spark script and run it through the Spark submit method. So this is again similar to what we had done earlier, but now you're running it on EMR. So first of all, let me clear the window. You need to first create a directory in workspace, and then change your directory. And now use nano, and let's call it wordcount.py, and copy the code from the lab sheet in order to now use it, right, as a script. So you can see I will paste the whole thing here. Not very long, right? And then you can press Ctrl X and then press yes to save the modified buffer, and now save it as wordcount.py. Once you get this, you can now copy the next command and then paste it, and you can see this is a Spark submit script where you want to do a deployment, and you have defined this is the script that you are interested in, and this is the data set, and this is where the output should be, wc spark out. So paste this, and you see the command will be executed. You don't have to press enter, and this is where you can see Spark is being executed, right? And you can see very soon it will be done, and you can also check how much time does this need to execute. So now we are running the Python or the PySpark script, right, on the Hadoop HDFS. And you can see, even though we could expect this to go faster than MapReduce, but I think the reality is, with all the processes involved for such a small data set, it will take a bit longer than 30 seconds, which is what we see earlier. So you can see that's almost 1 minute, right? And that is okay, possible. And next thing, we will try the S3 approach. And if you have forgotten the S3 list, right? Okay, we can also use this command to see it, and then you paste it somewhere, right? And now you can copy the S3 code, so you can see here, and the bucket ID you have copied earlier, you can now replace it here. Okay, and for those who are sharp with your observation, you notice the bucket ID here may be different from the video segment before this. Is because this setup is also, set up differently from the previous one. The operation is the same, but some of the naming may be different. But don't worry about it, right? I'm doing multiple videos or at different times with different cluster. That's why the IDs may look different. Okay, but the steps are the same. So once you have done this, press paste, and you can see it will be executed. And similarly, you will run, and you will look for the S3 dataset, and will also carry out the Spark script, right? But this time no longer on the HDFS storage, but it will be accessing the dataset from S3, and also the output will also be written to the S3 directory. So we'll wait a bit until this is done. Then you can look at the time. And also, if you want, you have the example code earlier, how you can access the output, right? And I think I'll leave all this for you to experiment and try out next. So I would expect this script to take about the same time. You can see it's 53 seconds, so it's almost 1 minute, which is consistent with the earlier example also. So at this point, you're done with today's lab, and what I want you to do is to look at the different steps you have carried out. And if you look at part 6, there will be this comparison table that would need your attention, where you can fill in, right, the different values. So that table, you can now look at the different timing. Right, let me change my screen a little bit. So you can see in this table, right, we have put in for you to fill in the different information. And I think this is a good summary if you can compare things from your lab 3 and 4, and also lab 5, what we do today. And you can create other columns with the different setup you have, so that you can look at the overall performance, and then at least have an understanding what are their differences, how you can make use of it in order to then do the comparison that can help you to further experiment with the skills we have taught you from lab 3 until lab 5. So feel free to modify this table according to whichever you want to compare. And now you have already the different options that I think you can also draw your conclusion which setup could work better, especially for future analysis that you would like to carry out, and also, of course, the project that you want to do next. A final step before we end, I would like to suggest you may want to consider this, to terminate your cluster, because if you do not do that, the good thing is EMR will automatically terminate it after 1 hour of idle. That means if you do not use it for 1 hour, it will also automatically be terminated. But if you can follow this step and terminate it before, right, you stop all your activities, then for sure the extra 1 hour of idle time will also not be calculated towards your usage. So you basically can save 1 hour of credits. It may not be significant, but I think it's good to build this habit for EMR. Whenever you are done, you can terminate it, because it will be terminated anyway after an hour, and every time when you don't do this, it will continue to cost you, right, credits. And therefore, I think that shift of mindset, this is quite different from the AMI approach, right, that you set up using the image I've provided through EC2. Those instances will not be terminated automatically, right? Then those will continue running. That the more you think about it, maybe it is not a bad idea, but that the AMI version, of course, will be more troublesome to set up. That's why we leave it running. But for this, you have already experienced today, to create the EMR instances is really quite automated, right? Most of things are managed by AWS, and therefore the termination is really not a big problem. So going back to this screen, how to terminate it is doable. You go to the clusters, you click on this button, you just click on terminate. Confirm that by clicking yes, and you see it's now being terminated. So terminating, and very soon if you refresh, it will end up as terminated. So this definition means once you terminate it, you can no longer use it, and you can't even restart it. But there's a good news. If it has been terminated, what you can do is select this and you can click clone. What happened is, I'm going to show you just a demonstration. If you click on clone, you see that you come to the interface where it looks almost similar to how you have set it up. But in this case, you don't have to do the setting anymore. All of them are set up exactly identical, right, to what you already know. So you can even see, the firewall and all these things are the same. Therefore, by clicking clone, you can quickly come here, click clone cluster. You will be able to then recreate this cluster without even going through the setting again. So therefore, I think don't worry about terminating it. The trouble to bring it back for you to use is not difficult. Just select a terminated version of what you have done previously, click clone, and you can now clone cluster to continue working or practicing. So with this, I hope you have a good experience learning Lab 5 using Hadoop and Spark on EMR. And I hope with this you have better understanding on the system, and you can also begin playing with data sets of your own to practice, to understand, and I hope that also gives you better understanding and experience with big data analytics in the cloud. Till our next lab, see you and bye.